All right, 3EB, descriptive geometry, and it's more angle between a line. The scenario you're giving here is like you're a deep sea operator and you're having to run the lines outside, like you're welding, or you're going down to check things for your drilling well. Because just say for an example, you only have a specific line of sight of which you can see out to look at things. So we need to know what that angle is, because you would need to go in, okay, if I know what that angle is, what their line of sight is, I need to do the best I can to make sure that they're in the best position so that they can best view and see what's going on. So that's just kind of a reason why we would find an angle for this one. So we're going to start off again as usual, and we want to be able to project our lines over. Now this time we're not going to draw them over horizontally because we're going to draw them perpendicularly. We want it to end up being perpendicular to this line here. So this now is our point of reference. So what I'm going to do, again, use my triangle, because I've given you the fold line. There it goes. Let's tape it down. I'm going to take the bracelet off because it's getting in the way. Okay. So what we want is we want a perpendicular to that. And if you want to make sure that, how do you know that you've actually gotten that? Bring that over. I put a triangle in that corner because they're perfectly 90 degrees. Notice that that lines up perfectly 90 degrees with it. So when I bring that over, it's my horizontal line because I used just to get the vertical in there, I've got a perfect 90 degrees, which is what we need. We need that perfect 90 degrees to get that perpendicular point. So let's do them all real quick. Actually, let's not do all of them. Let's go ahead and find our longest distance, which is out here to 0.4, because we don't want to go too far here. So from here to 4 to 4 is essentially the no, brain part. I don't want that one. I want it down here. We need to find the longest distance down here because we're going to transfer the distance from here to over here. Sorry, I got ahead of myself. Okay. For that, now let's go ahead and draw them out so we got it taped down. It's not going to kill anything. Transfer those measurements later. Okay, just went ahead and drawn down. Since I've already taped it up, I jumped ahead a step. There we go. Line it up, Colin. There we go.
Okay. Thank you.
Okay. See how that lines up to the B, to the C. Not that one. 6. Come on, you. There we go, sorry. 6. Okay, see, everything lines up, so we know it goes there, and that's where we're going to find those measurements that we need to find. So our farthest distance out is going to be down here to 0.6, so that's going to become our distance E. So from here to here is the E. Our shortest distance is the A, so that would be here. Then our next shortest distance is B. So I'm just going through here, which should be to C here. Then the next one is C, and then our next one would be the D and the E. So I'm just finding those different measurements. So farthest distance out. Farthest distance out. So I can mark it there. And then I'll go ahead and mark the shortest distance, both of them. real quickly. You know, go back and line it up. And all I'm going to do is just go ahead and make my straight edge. There it goes. So I've taken that straight edge and made sure that it's running with the lines here. And again, if you're not sure if it's doing that, just take your triangle, line it up on there, and if that triangle forms that perfect 90-degree angle, you know you've got it right. So we have now distance A. Let's go ahead and find distance B and transfer it. Find B, transfer it, B, C, D, and we'd already found distance E. So we got all of our measurements. Again, you don't have to label it, but I just find it easier for visualization if we label it. That's all it is. It's a visualization tool to help you find and draw all those. All right. So let's find the true size of the angle. Triangle, what does it look like, of the auxiliary view to here. So let's just start off by transferring some points. So let's go ahead and find 5, 4, 6. So let's find that. So I know 5 looking at it, max to here, and it's going to go on distance A. So I'm follow it here, 5. All right, let's go ahead and find 6. 6 is to the outside here. 6 goes all the way to the farthest point E. So I follow here to here. Should be 6. 4 should go in C, and it follows here. Make sure you're following the right one. And that should be 4. So let's see, does it correct? Does it build it? And yes, it does. Get my darker lead. And I'm just going to go ahead and draw my line right there, because that's where it intersects at. So there's line 6. 5 with 4 that intersects with it. All right, now let's find CD. Same thing again. I know C is going to be dimension B. I follow C here, come back to where the B is, mark it, C. All right, let's find D. D, oh, that's too funny. D is on D. So here's D on D. D. Now with this, we can actually construct the true size of what this triangle looks like. And then after we find that true size of the triangle, then we can again find the true size of the angle down here. So we had to find this so that we could get the next. All right, so, okay, next up, what do we do? All right, so we're gonna have, again, we're gonna follow that line that's gonna make it parallel. So we're gonna draw a line parallel to 5, 6 through 2. Tape and move. Tape and move, tape and move, tape and move. So it's going to be parallel to 5, 6, because that's our edge view there. Okay. Two. And then again, I want to find the shortest distance that I'm going to transfer, and we're going to be transferring off of this view. So the shortest distance on this one is right here, which is the F, all the way out to the longest one, which goes all the way out to I, to number 4 here. That's the J. So let's go ahead and find our farthest distance. Get that on our divider, because that's how far down we're going to bring these lines here, and we don't want to go down too far. So I know it's going to come down about right there. So, keeping that perpendicular line using our triangle. For some reason, I'm always paranoid that it's going to shift a little bit, so I'm always going to double check. Measure twice, cuts once was drilled into my head. So I've got the longest distance here now of the J. So I have the longest distance. And now let's just draw everything down. Let's transfer our measurements. So we got J. Let's just work our way backwards. Our next one would be I, which is going to be the distance here from this edge to D. So from that little point for D to here. That's going to give us our distance I. That's our I. Next would be H, which is going to be out here to 6. H. H. Next one is going to be the G, which is to this point, to this, no, it's not that point. Which point is it? Hang on, brain fart. Brain fart, come on, brain work. It's the 5, yep. Now 5 is F. G is C. There it is. Make sure I get the right one. There we go. So from the fold to the C. And then of course the smallest one, F, which is just barely smaller than G. It's a really tight fit. F. And as always, you don't have to do the labels, but I find it's helpful, especially when you're playing this game of connect the dots. Alright, so let's go find that true size of that angle of the 4, 5, 6. So let's transfer over 4. Let's go find 4 first. So 4 I know is along this line, and if I'm looking at it, the 4 is the farthest distance out, so it's that J. So I follow this line here, the 4 back, hits here, comes here, right, and hits the farthest spot out here. So there is our 4. Let's just go to 5. Okay, 5 is along this line, 5 comes to here, 5 is here. 5 is distance F. 5. 6, 6, and 6 is distance H. So we now have this triangle. I got my thicker 0.9 lid. Got 4, 5, and 6. We need to find CD so that we can eventually find those piercing points and where they come through. Okay, so let's do that. So C to here comes down here, and I'm looking at it, I know it's in the distance G. So I follow that line back on there, I find where that hits, and that would be right there. And then I'm going to find D. There's D, and D hits on distance I. Which is to right here on the edge of that sucker. So it's right there. Which makes sense because see how it's on that one? So it's right on that edge. And I'm going to draw it lightly first. See, because I got off a little bit there. There we go, that's better. You wouldn't think being off just a little bit makes a difference, but it does. And I'm going to make that the side right here. So here's C, here's D. We now have the true size of the triangle. Now we need to find the angle of the triangle. So we go through this process again. Remember that whole parallel perpendicular. So to find we're going to find the edge view, essentially this 5, 4, so we can get the triangle. So we want it to be parallel to this 5, 4 through 0.3. There it goes. Line it up. See, all this is now 5, 4. And this one starts to get a little crazy because we start to find all kinds of new dimensions we're trying to find here. Okay, let's find our longest distance that we need to have for this one. The longest distance we need to have is going to be distance M, which is going to be the farthest from C to here. That becomes our M. And then our L is going to be from 6 here, so that's L. And then K is going to be the shortest one. It's going to be that little distance from there to K. So I'm going to find my longest one, which is this one, and bring that out so I can get this. And it would help if I'd bring my perpendicular lines down, wouldn't it? So I would know where I could draw that. Find M, transfer M. So from here to here is that M. And then we need to find our L. L is here to here, there to there. L. And then of course the last one, which would be the J. Okay, sorry. Learn my alphabet going backwards. Little K.
Just getting all the way there.
Okay, draw those lines. Bring all those lines down perpendicular.
Fast typer, man. I hadn't opened up the email, but I saw you.
Okay, again, we're going to play a game, connect the dots. Let's go ahead and find 5, 4, 6. So we know 5 is here. And I know reference to 5 is going on that distance of L. So 5 and L meet right there. So that gives me 5. We're going to find 6. So 6 is on this line here. So here's our 6, right? 6 is to here. And 6 is also on that same L. So I bring it down until we hit 6. And then the same thing for 4. Where is 4? 4 is there, and 4 also goes to that distance L. So it goes here. So there's our 4, 5, 6. And right there is where 6 intersects it. All right, let's find DC. All right, same thing. D we know is going to measurement K, so we find D right here, and that meets right here, so that's D. C meets here, and C goes all the way out to the farthest measurement, so that goes to there. So we now have C, D. You now have the true angle. And just like previously before, my advice is to go ahead and draw your lines out for this angle far enough so that you can lay your protractor on it here later and measure to find that angle. So I just brought that out. Alright, so now we know where their piercing point should be because we have the actual true piercing point here in the triangle view. So now we're going to bring that up to where it hits here. So we know it's going to hit right there. Alright, so we know it hits here. This side here is going to be our solid part we can see, and this side over here is the hidden part that's going down inside of it. So line it up. Visible, hidden. Then we got to bring that one over, just like we did previously. There it goes, lining it up. I got to get it perpendicular. There it goes. And if you did it right, it should hit here, which it did. Sorry. Move my paper on me. I didn't tape it down. That's why you tape it down. I'm going to try to move it up so you can see it also. Okay, there we go. Okay. So then I can come here. Lightly draw that in. I know that it hits here, so that's where that's going to go. From here to here will be hidden. From here to here is your visible, because that's your piercing point. So we found our piercing points, following those over, and then don't forget, for the love of God, take your protractor, line it up, find out what that angle is, and then write that down, because you got to tell me what the true angle is. So take your protractor, line it up, and you'll get it. And then, of course, tell me what the angle is. Fill out the title block, draw over the lettering giving to you, put in the date, put in your name, turn it in. All right, now we get to go on to skewed lines.